In this problem, we're given 6 examples of a force being applied on a door in different directions and at different locations. We were asked in each case to find the magnitude of the torque and find the direction that the torque is acting in. For each example, we need to determine the force vector, the vector r, which represents the distance between the pivot and where the force is applied, and the angle theta, which is the angle between the force vector and the r vector when they're aligned tail to tail. In the first part, the force vector is being applied the full distance r away from the pivot. The angle between these vectors is theta. Using trigonometry, we can see that this angle theta is the same as that angle theta. The magnitude of the torque is therefore L, the length of the door, times F, the magnitude of the force, times sine of this angle theta, and using the right-hand rule, where we point our fingers in the direction of r and cross our fingers towards the force vector, we see that the torque is pointing out of the page. In the second example, the force vector is again being applied the full distance r away from the pivot point, so the magnitude of the torque is the length L of the door times F, the magnitude of the force, times sine of theta, where we know again from trigonometry that this angle theta is the same as the angle theta between F and R when they're aligned tail to tail. Using the right-hand rule, we point our fingers in the direction of R and curl them towards F and see that the torque points into the page. In the third example, the force is still being applied the full distance away from the pivot point, so the magnitude of the force is L, the distance from the pivot to the edge of the door, times F, the magnitude of the force, times sine of this angle theta, where, using trigonometry, we again see that this angle theta is the same as this angle theta, which is generated when the force vector and the r vector are aligned tail to tail. Using the right-hand rule, pointing our fingers in the direction of r, curling them towards the force vector, we see that the torque points into the page. In the fourth example, the force is being applied directly at the pivot, so the r vector, which represents the distance from the pivot to where the force is applied, is equal to 0. This means that the torque is also equal to 0. In the fifth example, the force is being applied about halfway between the pivot and the edge of the door. So, the magnitude of the torque is therefore equal to L over 2, where L is the distance from the pivot to the edge of the door, times F, times sine, this time, of the angle theta plus 90. Because when we align the vectors r and f tail to tail, we see that this angle theta is equal to this angle theta, but the full distance between the r and the f vectors is theta plus 90 degrees, which is why we have this term here. Using the right-hand rule, we point our fingers in the direction of r, curl them towards f, and see that the torque is coming out of the page. In the final example, the force is being applied about half the distance from the pivot to the end of the door and is applied in a direction which is parallel to the length of the door. This means that the angle between r and f is equal to 0, so when we go to calculate the cross product, we have sine of 0 degrees, which makes this whole term equal to 0. So the torque in this case is 0.